Greeting. Peace be with you. In this video, I am going to introduce to you my initial porting of DumbDisplay Arduino Library to MicroPython. The porting is not complete, nevertheless, a large portion of the functionalities of DumbDisplay have been ported. Hopefully, this should already be helpful for friends that use MicroPython for developing programs for microcontroller boards. For an introduction to DumbDisplay, you may want to watch my previous video, introducing DumbDisplay, the little helper for Arduino experiments. In this video, I am going to show 4 ways of making connections to DumbDisplay Android app. The first 2 are targeted for ESP32, the third one is targeted for Raspberry Pi Pico, and the final one is targeted for Raspberry Pi Zero W, which uses regular Python. I will assume that you have Git and Tiny installed, and hence I will not show the steps to install these 2 common software for MicroPython development. I will also assume that you have the DumbDisplay Android app installed. To download the needed MicroPython firmware for the 2 target microcontroller boards, ESP32 and Raspberry Pi Pico, head to the download page of the official MicroPython website as shown. First for ESP32. Then for Raspberry Pi Pico. Of course, you will need to get the DumbDisplay MicroPython library as well. One easy way to get the library is to clone the project from GitHub. Head to the MicroPython DumbDisplay Library Project's GitHub repository. Copy the code URL and paste the URL to command prompt as shown. Notice that the project is cloned to a specifically created directory for this video. Now, you can proceed to use Tiny to set up your ESP32 board for simple DumbDisplay experiment like this. You may want to focus to the DumbDisplay MicroPython library project first. To upload the firmware you downloaded to your ESP32 board, choose the menu item Run, select Interpreter. In the dialog box popped up, select the interpreter for ESP32 MicroPython. Then click on the hyperlink Install or Update Firmware to initiate download firmware. In the dialog box popped up, choose the port your ESP32 is attached to. Normally, there will be a single item shown. Then browse to and select the firmware you downloaded previously. Lastly, click the Install button to start installing. If everything proceeds well, you should have MicroPython installed to your ESP32 board. Upload the whole DumbDisplay folder to your ESP32 board as shown. This folder contains the complete MicroPython DumbDisplay library code. Now, let's program a very simple MicroPython script, which is also included in the MicroPython DumbDisplay library project. Focus into the very simple sample folder as shown. This script will be using Wi-Fi to connect to your DumbDisplay Android app. Hence, you will need to set up Wi-Fi router credential, with a MySecretPython script file as shown. Now, upload both main.py and mysecret.py to your ESP32 board. The MicroPython script main.py will be run automatically, every time your ESP32 board reboots. Before seeing the result of the MicroPython script, let's review the script. Line 6 imports the secret Wi-Fi router credential you just created previously. Lines 8 to 10 import the DumbDisplay stuffs. 3 main areas are needed. First is the core DumbDisplay object. Second is the connection I/O mechanism. Third is the layer to show on DumbDisplay Android app screen. Line 13 imports the standard time library to pause during script execution. Line 16 creates a DumbDisplay object and assigns it to the variable dd. Notice that the I/O mechanism used is Wi-Fi, which the credential values you set in mysecret.py. Line 17 creates a LED grid layer with 2 LEDs horizontally, and assigns the layer object to the variable L. Line 18 sets the off color of the LEDs on the LED layer to green. Note that by default, the on color is red. In other words, when LED is on, you should see a red dot, and when LED is off, you should see a green dot. Line 19 turns on the left side LED, on position 00. Effectively, the left side dot is red, and the right side dot is green. Line 20 loops for 10 times. In the loop, line 21 pauses for a second. Then lines 22 and 23 toggle the two LEDs on and off. Finally, after the loop, a comment is written to DumbDisplay Android app. Now, let's see it working. Simply press the reset button on your ESP32 board, and the MicroPython script main.py you just uploaded should run automatically. Please note that in order for your DumbDisplay Android app to make Wi-Fi connection with your ESP32 board, you will need to enter the IP as shown, to your Android app. For this demo, I will not be using a physical phone, instead, I will use an emulator. Next, I will modify the MicroPython script main.py directly to use ESP32's BLE for connecting to Android phone. First, close the main.py tab, which is the main.py file in your computer. Then, open the main.py file in your ESP32 board as shown. Now, you should be able to edit it directly. Delete the lines concerning Wi-Fi credential, since you will not be using Wi-Fi anymore. Change the import IO line to import BLE instead as shown. Change the line that creates DumbDisplay object to use BLE as shown. Note that the name of the BLE device is DD-test-BLE. After the code change, remember to save the changes you made. Then, again, press the reset button of your ESP32 board. After the ESP32 board rebooting, you should see in the shell the message, waiting for BLE connection to DD-test-BLE. Now, your phone should be able to make connection via BLE as demonstrated. Next, I will switch to run the similar MicroPython script with Raspberry Pi Pico. Since Raspberry Pi Pico does not have built-in remote connectivity provision, I will attach a HC06 Bluetooth module to its UART1. I will assume you have already set up the HC06 Bluetooth module in the desired way. For this video, the HC06 is set up with name Pico, and is set up to the baud rate of 115,200. And here is the connection diagram of attaching HC06 to Raspberry Pi Pico. Connect RX of HC06 to GP8 of Pico. Connect TX of HC06 to GP9 of Pico. Connect VCC of HC06 to VBus of Pico. Connect GND of HC06 to a ground pin of Pico. To upload MicroPython firmware to your Raspberry Pi Pico, choose the menu item Run, select Interpreter. In the dialog box popped up, select the interpreter for Raspberry Pi Pico. Then click on the hyperlink Install or Update Firmware to initiate install of MicroPython firmware. Upload firmware is a bit more involving, but still easy enough. Just follow the steps shown. Click Install to start flashing. Note that Tani actually provides the needed firmware automatically. If everything proceeds well, you should have MicroPython installed to your Raspberry Pi Pico. Now, change the left panel to the folder MicroPython DumbDisplay, then select and upload the DumbDisplay folder to Pico. Then, navigate to main.py in very simple folder, and upload it as well. The main.py uploaded to Pico still needs a bit of modification. Open it with Tani as shown. Delete the lines concerning Wi-Fi credential, since you will not be using Wi-Fi. Change the import IO line to import UART instead, as shown. Change the line that creates DumbDisplay object to use UART IO object, as shown. Notice the arguments given to creating the IO object. After the code change, remember to save the changes you made. Similar to ESP32, main.py will be run automatically when Raspberry Pi Pico reboots. To reboot your Pico in order to run main.py you just saved, simply press Ctrl D in the shell. This will soft reboot the attached Pico. Now, you should be able to connect your phone to your Raspberry Pi Pico. Let's see it working. The final target for this video is Raspberry Pi Zero W, which is a single-board computer that supports regular Python 3. Here, it is assumed that your Raspberry Pi Zero has SSH enabled, so that Tani can be used for remote Python development. To do remote Python development with Tani, you will need to select an interpreter. With the menu item Run, select Interpreter. In the dialog box popped up, select Remote Python 3 SSH. In yet another dialog box popped up, enter the details for accessing your Raspberry Pi Zero via SSH. If Tani can connect to your Raspberry Pi Zero via SSH, you will see the folder tree in the left bottom panel, as shown. You may want to create a directory for this experiment, and focus into it. Then, copy the whole DumbDisplay folder to it, as shown. Also, copy the Python script file main.py in sampled doodle folder. You will run this Python script file from your Raspberry Pi Zero. Before running the script, let's review the code, which uses DumbDisplay to realize an extremely simple doodle app that allows you to draw end-to-end lines with 3 different colors. Lines 2 to 5 import the needed DumbDisplay stuffs. Lines 9 and 10 will come back here a bit later. Line 31 creates a DumbDisplay object, and assigns it to the variable dd. Notice that the IO object used is for accessing the outside network, the internet. Lines 34 to 36 creates 3 LCD layers as 3 tabs for changing the draw color, and assign them to the 3 variables LR, LG, and LB respectively. Lines 39 to 41 set the 3 LCD layers, that is the 3 tabs, to the colors, red, green, and blue respectively. Line 45 creates the main graphical LCD layer on which to draw lines to, and assigns it the variable L. Lines 48 and 49 set up the background color and border for the main graphical LCD layer. For the 3 tabs, lines 52 to 54 enable user interaction feedback, like clicking, and route the feedback events to the same handler, feedback handler. For the main graphical LCD layer, line 57 similarly enables feedback, and routes the feedback events to the same handler. Note that for this graphical LCD layer, the option for auto repeat every 50 milliseconds is also set. Line 60 auto pins the different layers, the 3 tabs in the main graphical LCD layer, in the desired way. Finally, lines 63 and 64 define an infinity loop that simply call DumbDisplay delay method again and again, giving chances to DumbDisplay library to do its work. Now, let's get back to the feedback event handling code. Lines 9 and 10 initialize some global variables to store last position, as well as draw color. These global variables will be accessed by the feedback event handler to be defined next. Line 13 starts defining a subroutine as the DumbDisplay feedback event handler. The useful parameters are 1. The layer clicked, and 2. The position clicked. Line 14 declares that last X, last Y, and color are global variables that will be updated in the subroutine. If the layer clicked is the main graphical LCD layer, draw a line on the graphical LCD layer between the last position and the current position, then update the last position to the current position. Otherwise, if the layer clicked is any one of the 3 tabs, set the draw color accordingly. This concludes the script. Let's see it working. To start running the Python script main.py, simply enter import main in the shell panel, which is a Python REPL. Once running, notice that the IP address for making connection is shown. You will need to enter this IP address to your DumbDisplay Android app.